everyone. Michael Unger here in Ground Station Canada, on site, the MacMillan Space Centre, the Ground Station Canada Theatre, which is located on the unceded territory, the Musqueam, Squamish, and the Tsleil-Waututh, for another edition of Ask an Astronomer. And who else are we going to bring in for that but our trusted astronomer, Marley? How's it going, Marley?
It's going good. Very excited to be back with another Ask an Astronomer. Lots of news happening once I finish the PowerPoint presentation, but that's fine.
There has been lots of news. I went camping recently, and they almost remoted me in. Yeah, and you got a chance to think a little bit about some of the news that's been happening. We're going to get to lots of news stories this week. We're going to talk about Ganymede. We're going to talk about black holes. We're going to talk about billionaires in space, and of course, because it has been really clear skies, at least here on the West Coast. Perhaps a lot of you out there have been looking up at the sky and been noticing lots of stuff. So we'll point out some things that you can see in the sky tonight and most likely for many of the next few summer nights. And if you're watching out there on YouTube land, say hello and let us know where you're watching from, and put all of your questions into the chat window on YouTube. And if you're watching on Telesoptic, then come on to YouTube and ask some questions. We will answer all of them, even if they're not related to some of the topics we are going to cover today. So Marley, let's get started with our first big story of the day, and that is a moon that is part of the Galilean moons, a moon that usually doesn't get a lot of love, but recently we've got some information that makes it a whole lot more interesting.
Yeah, so recently we've gotten confirmation that there is water vapor on Ganymede, more specifically in its atmosphere. So this is exciting. Ganymede's known as like a very icy moon. It's been hypothesized that it has a thick layer of ice as like a crust and then possibly oceans underneath, but there's never been even real evidence. We've just kind of ruled everything else out. And so that must be the case. But now we have actual evidence of water vapor on Ganymede. And the reason that the water vapor is so interesting is because it's a biosignature. So biosignatures are key to identifying potential life on different signs of life on different worlds. And so a biosignature could be any substance like an element or an isotope or a molecule or a phenomenon that gives scientists an indication of past or present life. So ours is water, because when we look for life, we only know how life has existed in our context here on Earth. And water is very, very important to how we are able to live on Earth. So finding water on a moon in our own solar system in vapor form, albeit, is still very, very interesting. So in this case, they were looking for H2O vapor, but a little more than that. And the team was led by Lorenz Roth out of Sweden, and they set out to measure the amount of atmospheric oxygen in the atmosphere of Ganymede. And they actually did this using the Hubble Space Telescope, which some people may know was actually out of commission for about a month there, but is now fixed and back to performing science operations. So that's We're really happy to hear. Yeah, I was very stressed for about a month about Hubble, especially because James Webb got delayed again. So no James Webb in October, mid-November, hopefully, but we'll see. And then Hubble being broken, I was like, oh no, but now it's okay. And they actually used archival data from the Space Telescope, data from 1998, and also data from 2010. And then they also took new data in 2018. And they've been working on it since, and the paper just got published very recently. And so what they wanted to do was look at the amount of atomic oxygen in the atmosphere of Ganymede. And one of my first questions was, why would you want to do that? And it turns out the reason why was because they were looking at these 1998 ultraviolet images of Ganymede. So that is Ganymede. This is a photo from the Hubble Space Telescope, but it's in the ultraviolet range. So our eyes can't see this. So it's been colorized so our eyes can see what the patterns that the telescope saw. So these ribbons are actually electrified gas called auroral bands, and you can definitely see them around the polar regions of Ganymede on the left hand at the 1356 picture, and they're kind of all over the place in the 1304 picture. So these images actually helped to provide further evidence that Ganymede had a magnetic field, which was very awesome at the time, albeit Ganymede has a weak magnetic field. And scientists at the time explained the similarities in these two observations by the presence of molecular oxygen. So atomic oxygen is just one oxygen atom. Molecular oxygen is like O2. So oxygen travels around most often in like a pair. They share a bond and they move around. That's the oxygen we breathe and things like that. Atomic oxygen would be just the one. So the two observations, similarities were explained by molecular oxygen that had been sputtered or hit with high energy particles and split into those two oxygen atoms. And that's what that diagram on the left shows. You have a high energy particle hitting a oxygen molecule, and it splits it into two singular oxygen atoms. So at the same time, though, there's a lot of discrepancies in these two pictures. So the discrepancies were thought to be because of high concentrations of the atomic oxygen that was coming from the sputtering. So they were like, oh, there must be molecular oxygen that's just getting bombarded with high energy particles. And now we have a lot of atomic oxygen, and that's causing what the differences look. Because this 1356 and this 1304 actually correspond to specific wavelengths where atomic oxygen gets excited and will output a photon or absorb energy. And so they looked at these two particular ones in 1998. That's what the telescope could see, and for many other reasons, because that it would work. And this is what they saw. And they're like, well, we're looking at atomic oxygen anyway. That must be the difference, is from caused by the atomic oxygen. Also, the features that they observed in 1998 did not match the expected emissions from a completely molecular oxygen atmosphere. So we also know that Ganymede is an icy moon. Possibly, we knew this back in 1998 as well. We've long thought that the surface is frozen water, so any water vapor in the atmosphere would not be because of the evaporation of Ganymede's possible ocean. It would be from what's called sublimation. So that is when it goes from a solid to a gas. And so Roth and his team looked at this and they're like, well, if that's the case, we should see atomic oxygen and water vapor in the atmosphere if this is what is happening in 1998. But they found no atomic oxygen in the atmosphere at all. They found some, but barely any, not the levels that the 1998 team had concluded. So what it boiled down to is what is causing the differences in these two photos. So the Roth and the team took a closer look at the image, and more specifically how these auroral bands are distributed. You'll see in the 1356, they're very much concentrated at the poles or at the top and the bottom, whereas in the red or the 1304, they're very much all over the place. And so they thought, I wonder if this has anything to do with how warm it gets on Ganymede. Like, even though it's so far away, the sun still hits it, if there's any warming on the moon. And so they did work, and it showed that the temperatures of Ganymede on the daytime side can get to roughly a bone-chilling negative 130 degrees Celsius. But there is a slight difference depending on your where you are on the moon. And the temperature actually varies quite a bit during the day. But at the equator, when the sun is overhead, or when we think of as noon, it may become warm enough for the surface ice to sublimate. So they were like, okay, with that in mind, it would sublimate and there would be tiny, tiny parts of water molecules now in the air. And so Roth and the team found that the difference in the UV images correlated exactly to where the sublimation would happen, where it would get warm enough for the ice to sublimate, and corresponded exactly to where the water would be expected to be in the atmosphere, which is very, very cool and a lot of very fun work, taking work from 1998 and basically mapping it with how temperature changes on the surface of Ganymede, and then being, oh, well, there's a definite correlation here. But how did they do this? It becomes a really big, fun question to get into.
Well, let's get into that. We do have some questions about this, Marley, and atomic oxygen certainly sounds like a 90s band if I've ever heard of one. But we do have a question about the atomic oxygen from Keith, who asked why wouldn't it just quickly rejoin with the molecular oxygen?
So molecular oxygen already has the two together, and so it won't take on anything else. And atomic oxygen on its own is actually highly unstable. So it will join with whatever it can find, or at least try to. But molecular oxygen is already together. And so there's a lot going on. And I tried to read the paper. I read the paper, and I confess a lot of it went a little bit over my head, but I did get the plots down. But the atomic oxygen is very unstable, and so it will want to react with whatever it can. And you have to remind, these exposures that they're taking aren't just like one picture. It's like over a long minutes of time. And the Hubble Space Telescope has specific instruments designed to look at specifically this. So a lot of these atomic oxygen that we're seeing visualized in this picture would have most likely been taken back, but more would have been broken apart. It's an ongoing process.
Okay, so a little bit unstable. So atomic oxygen, probably more like an Ebo band, maybe like pop sensibility,
Yeah.
something like that. So I'm curious though, Marley, because Ganymede classically, even back in the 90s, was always the forgotten Galilean moon. Like Europa, Io were the ones that got a lot of attention, and these readings were back in the 90s. So why is it taken so long for all of a sudden Ganymede to have this focus on it? Was there some impetus? Was there recent findings where scientists all of a sudden, where did the motivation come to suddenly look a little deeper into Ganymede?
So the motivation for Roth and the team that he worked with specifically came from, it was like part of a Juno support. So when Juno was first advertised, but like put forward as a possible mission, this was part of a Juno support, like scientific justification sort of thing. So it was like, if we launch Juno, we could look at Ganymede, right? And Juno did return some very interesting images of Ganymede not too long ago. And so it was part of that. And it also ties into the upcoming JUICE mission by the European Space Agency of looking at Ganymede more closely. Ganymede's like always been an interesting moon because it has ice, it might have this ocean, but one of the other problems is like getting close enough to see it. Is sending a probe there is very difficult, and things like that. So it was kind of like technology had to catch up to the interesting bits of Ganymede.
Interesting. Well, yeah, let's get into a little bit more of that JUICE mission that is going to be launched by the European Space Agency, which again was usually associated with Europa, but now Ganymede is going to be part of that. Of course, all of the Galilean moons are going to be a part of that. We do have a question from Ange who asks about the discovery of Ganymede. So does that go back to Galileo when he first looked at Jupiter through the telescope? Is that when essentially Ganymede was discovered?
Yeah, if I'm remembering right, it was around the time, Galileo, I think, saw, hence the Galilean moons. It was the four he saw. And originally, I think he tried to name it after one of the kings or something like that. But everyone's like, no, we're going to call it this, or the Medicis or something. It has a very fun history. The history of the naming of the moons is very fun and want to look into, but I'm pretty sure it was Galileo who discovered this one.
Yeah, I believe it was. They're all associated because Jupiter is the god, and I believe all of the moons are associated with the gods. I believe mistresses of Jupiter, I think, is how it goes.
Oh, okay, well, that makes sense.
Yeah, let's get into the JUICE mission because that's coming up in a few years, isn't it?
It's actually supposed to launch in 2022. So the JUICE is supposed to launch in 2022, which is just a fun thing to say. The JUICE is supposed to launch. And it stands for Jupiter Icy Moons Explorer. And so it's slated to start orbiting Ganymede in 2034, and it will orbit Ganymede for about 280 days, which is a very long time for the extent of the mission. But the Explorer will also go around Jupiter and also investigate Io and Europa, I think, as well, and more so the overall Jupiter and Galilean moon system. But they are have put it in to spend a mission focus at Ganymede, which is very fun.
Now, of course, that then makes Callisto the forgotten moon of Jupiter, but hopefully Callisto will get a little bit more love as well.
I think Callisto might be. It's either Callisto or Io who's not in it. I always forget which one it is whenever I remember the mission, but one of them is included and one of them is not. But for sure, Europa and for sure Ganymede are in there.
And what's really cool is Jupiter. We're going to talk a little bit about some of the planets that we can see in the night sky at the end of this presentation. But if you look at Jupiter with a telescope, which we do here at our observatory, you can see these four Galilean moons. And even on subsequent nights, you can even see them in different positions, something that any of us can go out and look. I think that's really cool. I was really amazed the first time I looked at Jupiter through a telescope and saw those Galilean moons.
No, I remember doing it back in Calgary during the Great Conjunction when it was called back in December, and with my family and seeing Jupiter. Well, granted, my telescope wasn't big enough to make out any details or anything like that, but you could see the point of light that was Jupiter, and then four little points of light, and then Saturn. And I remember my brother being like, "What are those like four little dots?" And I was like, "Listen, those are the moons, and it's super cool because they move, and it's so fun." Yeah.
Awesome. Do we have any more on JUICE before we move on?
We've got a bit more about JUICE, what it's specifically going to investigate. So it's going to investigate the magnetic field and measure the water abundance. Now that we know that there's water vapor in the atmosphere, or are pretty sure that there's water vapor in the atmosphere, it can measure it with specific tools that it has on board. And we'll look specifically at these two oxygen 1 lines where it emits from. So it's going to look largely in the UV, looking specifically for the concentrations of the oxygen when it emits at 1304 angstroms and 1356 angstroms. And it's going to look for latitudinal trends of water as well. So how does the water vapor in the atmosphere change over the atmosphere, over the planet? Because one of the conclusions made in the paper by Roth and the team was that the water vapor is kind of concentrated around the middle of Ganymede and kind of tapers off the closer you get to the poles, which is very interesting. So it's going to measure those trends and see exactly what it means. So really what Roth and the team did is make a great starting off point for experimentation for this JUICE mission once it reaches Ganymede in 2034, and also providing more things to think about and future considerations for the mission and future observations of Ganymede, which is really awesome and really great.
Awesome. Really looking forward to that. Make sure to look for some events we're certainly going to do around JUICE and Jupiter, probably over the next few years. But let's get back to possibly one of the biggest cool things in the universe, which is a story about black holes, something that I'm always drawn to. Of course, lots of things will be drawn into it if you're close to it. But one thing about black holes is that it's hard to see into a black hole. It's especially hard to see behind the black hole, but for the first time, we've now see some light behind a black hole. What's going on here, Marley?
Yeah, so this was fun, except that I had just finished all my Ganymede slides, and then I got that this story dropped, and I was like, all right, I guess I'll just make new slides. But it's still very awesome. This is from Chelsea Agode from space.com, talking about space telescope spotlight echoing from behind the black hole for the first time. So this is very fun. The two telescopes that were involved in this is NuSTAR, which is the Nuclear Spectroscopic Telescope Array by NASA, which looks for high energy X-rays, which is really important because black holes and their activity will often output in high energy X-ray bands. And it can look at energies past the XMM Newton telescope, which was the other telescope that was used to do this. So they got a wide range of data in the X-ray. And the XMM Newton, which is the one that looks like a more conventional space probe without the long scaffolding there, XMM Newton was tasked with investigating interstellar X-ray sources in narrow and broad range spectroscopy. So it already had quite a big range, and then NuSTAR tapped on an even larger range. And a fun fact about XMM Newton is that it was only planned for a 10-year mission, but it has actually been in operation for 21 years, 7 months, and 18 days, which I love. I love a telescope with a long life. It's great.
And another fun tidbit for anyone, I know you probably haven't seen it, Marley, but for anyone out there that's seen the original Disney's The Black Hole, the spaceship actually kind of looks like the probe if it were scaled up with that long scaffolding in the middle. It's kind of a weird movie, but if you're a diehard weird Disney movie fan, go check out The Black Hole. The science not so great, but some fun robots in it.
Is it ever? But listen, the science is good for the time, always. You know, they interpreted it fine. But yeah, so they saw this echo behind the black hole for the first time. And so this infographic is actually from the European Space Agency. And it's a lot of text, more than I'd like, but it's a really, really good graphic at explaining kind of what I want to talk about here. So the ESA's XMM Newton and NASA's NuSTAR space telescopes and an international team of scientists observes bright flares of X-ray light coming from around a black hole. So it's very hard to see anything behind a black hole because of how much the black hole warps, you know, space-time. And so once light crosses the event horizon, it can't get back out. And so that's the main thing, is that it can't escape, light can't escape, and we see everything in light. And so if there's no light, we can't see. Big problem. But what happened with this is that there were X-rays that echoed off of gas that was falling into the black hole. So the black hole in this diagram, oh my gosh, my laser pointer, finally. The black hole in this diagram here has its own little amount of gas that's kind of coming around and going around it. So gas is falling in to it, and it's causing the X-rays are echoing off of the gas, and that is producing this little flare coming off of it. So what happened is that the scientists were looking at this and they didn't actually expect to see anything from behind the black hole because light can escape from it. So it was never an expectation for them. But the black hole warps gravity so extremely, especially the specific one, so that the light echoes from behind it. So it's kind of like if this black hole were here, there was like this well here. It's like sitting and dipping down, like if you sit in a very cushiony bed, and then the light would actually dip through and come out the front. And kind of echo from behind. And so it was bent around the black hole, making them visible to XMM and New Star. And so it was very awesome. They were much fainter than they would have seen it before because of its travel and very faint, but it was still very awesome. And so what they were actually investigating was the corona, which is this big thing here in this diagram. And the corona is a part where it's a source of very bright X-ray light, and they wanted to find out more about it because it's not very well understood how it works or when it comes from and when it stops and how all that happens. And so we think that the corona comes from the gas that falls continuously into the black hole, which becomes the spinning disk. And so this echo actually helps them answer some questions about the extreme gravity and possibly how the corona works there. So it was very fun discovery. Very congratulations to the team who saw it.
Awesome. Yeah, really fun stuff about black holes. And hopefully, when James Webb gets up there, we'll get even some more fun stuff about black holes, but also the big telescope, the
extremely large telescope.
The extremely large telescope. That was the one I was looking for. I knew it had a big name. The one that can also give us some more information about black holes. Okay, if you got any questions about Ganymede or black holes, throw them into the chat. We've got a couple more news stories, including a kind of a weird one that, Marley, you and I have both had a chance to talk to some media news stories, because some of the big stories that have come out recently have been about the space tourism that's been happening. I was on CBC talking about Richard Branson. I know that you almost got the chance to talk to Ian Hannah-Mansing about Jeff Bezos. And we talked about the Kármán line. We talked about sort of like that level of where space is, but now there's this other distinction and kind of controversy coming up about who gets to call themselves an astronaut.
Yes.
And some new news has come out about that.
Yeah, so this is an article by Denise Chow from NBC News, and this is who gets to be called an astronaut. It's very complicated. And I remember even when Richard Branson was going up and Jeff Bezos was going up, questions a lot of, well, are they astronauts? Like, aside from like, are they even going to space, which was a whole thing. It's, well, are they astronauts if they go to space? What is an astronaut anyways? And so because human beings like to define things, turns out there are a lot of definitions for what makes an astronaut an astronaut. But in the United States, there are only 3 agencies that can designate astronaut wings or astronaut status onto people. So that's NASA, the US military, and the FAA. And so for NASA and for the US military, if you fly in a vehicle over 80 kilometers in the air for the agency, so either for NASA or for the US military, you will get the designation of astronaut, but you have to do it for them. There are also other types, like a lot of other types of astronauts. If you fly to the International Space Station in a mission coordinated by NASA and Roscosmos, you're a spaceflight participant. If you fly to the ISS on a privately funded, specifically dedicated commercial spaceflight that has a commercial launch, which also does commercial or marketing activities on the space station, you would be called a private astronaut, though to this date, no one has done this. And there's also a generally accepted but unofficial term for a paying non-crew passenger who flies on a private non-NASA or military vehicle above 80 kilometers, and that is a space tourist, but it's not an official term. So it turns out there's a lot of words. We really like to nitpick what happens. And so for a while there, the FAA's definition was if you fly above 80 kilometers in a non-NASA vehicle as a crew member, you would be called a commercial astronaut. That's it. That's done. So Richard Branson and the crew there and Jeff Bezos and the crew there would be called commercial astronauts. They did get over 80 kilometers and they did fulfill some other requirements that the FAA had out. But on July 20th, the FAA revised these rules. And so they actually changed it and added this clause in here. This clause says that it's like part C down at the bottom says demonstrated activities during flight that were essential to public safety or contributed to human spaceflight safety. So under this new clause, people who pay for suborbital or in the future orbital flights are ineligible to receive astronaut wings because they did not do something essential to public safety or contributed to human spaceflight safety at all. But here, even with this new clause, it's still very murky because Virgin Galactic and that flight that Richard Branson went on was a designated test flight. So there is an argument to be made that the crew performed tasks that contributed to the safety of human spaceflight just by flying and just by being on the test flight itself and testing the technology. However, for Blue Origin's Jeff Bezos flight, it is pretty clear cut that this no longer applies because the entire New Shepard module and entire New Shepard and the Blue Origin team, they flew on something that was entirely autonomous. So no one had to fly it. There was no one testing any technology. And so passengers did not really perform any essential tasks during the flight. But then you may think, okay, well, that whole crew, or passengers crew, no astronaut wings for you. But there's a further murkier part in that Wally Funk may still get an exception, the woman who flew, because the FAA can award honorary astronaut wings to quote individuals whose contribution to commercial human spaceflight merits special recognition. And I would argue that Wally's does. So it becomes this whole very murky who's an astronaut, who is not an astronaut, who's a commercial astronaut, who is a space tourist. And so I kind of wanted to end everything off with what should we call them? Because there are only going to be more people going to space. So what in the world should we call them? If not astronaut, if not commercial astronaut, then what?
Yeah, we should, put into the chat if you're watching on YouTube, what should we call these? Space tourists? Really, if it's really about the bragging rights. You can like be there, cocktail party, and you can say, I went up into space. I mean, that's really all it comes down to, right? Pride suggests space baron.
Space baron.
But then the barons are going to get upset about
are there
that.
Still barons?
There's probably some barons out there.
Okay.
Maybe in Europe somewhere, I think.
Okay, yeah.
But the other cool tidbit about that Blue Origin flight is that Wally Funk got to go up, and she was a pioneering female pilot that was supposed to go to space and was supposed to be an astronaut back in the 1960s. So I thought it was really cool that she got to go on this flight and finally got to get up there.
Oh, agreed. Give Wally Funk her wings. That's all I have to say. Give her the wings. Yeah. Very interesting woman.
Awesome. Well, before we end off today, let's take a look at the nighttime sky, because like I teased before, lots of people are going out. You can go out tonight, maybe find Jupiter. I was out camping and I saw the stars in their full glory. It was really exciting to be out in a dark sky to see them again. So if you're out there and looking up, what can we expect, Marley?
So definitely, I'm going to keep talking about this till they're gone. Jupiter and Saturn, you can definitely see right now. In the evenings after sunset, they rise in the east-southeast and they set in the west-southwest. And actually right now, there are two meteor showers going on, the Southern Delta Aquarids and the Alpha Capricornids, though they are coming to a close pretty quick. And they're both two very faint meteor showers, but both of their radiants, which is where they appear to be coming from, are located right very close to Jupiter and Saturn. So if you're out viewing and you see meteor across the sky, you're looking in the direction of Jupiter and Saturn, I just think that would be a very fun moment to see all that happen. So definitely check out them. If you have a telescope and you're viewing Jupiter, you could have a chance to see the Galilean moons and get a very small sneak peek at what Juice would see a much better image than you will, but hey, it'll still be fun. And then also coming up, you can see right now has been up is the Summer Triangle. So a Summer Triangle is an asterism made up from the bright stars of three constellations, Cygnus, Lyra, and Aquila. And so if you look for Vega first, it's the brightest star when you look straight up, and then you will see two other bright stars making it. It's actually much larger than you think it is. Don't be fooled by a small triangle. It's quite big, takes up a good chunk of the sky, and you'll be able to see that as well in the night skies tonight.
Awesome. Make sure you get out there to check out those stars. Just back on what should we call the space tourists. Keith just says passengers is fine. Space passengers. I like space passengers. That's fine.
That's good. Yeah, that's what they are.
And plus a pretty cool Iggy Pop song as well. And if you do have any questions, you can email them to Marley, not Rachel.
Not Rachel, my bad, missed that.
We do miss Rachel though.
Yes.
But it's the exact same email address. It's astronomer@Space Center. And you can also go online, check out our other resources we got up there. And like Marley said, meteor showers are coming up. So on August 12th, actually August 11th, we're going to be doing an online event. So if you're outside of the Lower Mainland and you want to tune in to all about Perseids, we actually even have an eye scientist that's going to talk about how our eye adapts, actually figure out what's going on inside of the eye. You can tune in to that online event, but then we're also going to be in our backyard, Vanier Park, and Marley and some of our interpreters are going to be out there looking for those Perseids and hopefully navigating where to find Jupiter, Saturn, the Summer Triangle, all sorts of fun stuff up there using the Natural Planetarium in our backyard of Vanier Park. Taking advantage of maybe the last year we get to do some stuff out there because Board and the Beach usually takes over out there. So come on down. You can get a ticket on our website, spacecenter.ca. Oh, you know what? We have one final question that just got in before we end off today from Ange, who asks, sometimes Ange sees a white dot, some brighter than others, moving across the sky, sometimes several at night. Is this a satellite? Could this be part of the other billionaire Elon Musk's constellation satellites?
Yeah, so the first time I saw the Starlink constellation, it really kind of freaked me out because I was like, am I seeing something? But it is that. If you see, it most likely is that, a constellation of satellites going by, and the most ones that you do see are Starlink. I know a few more have gone up recently, and so they're much lower and so brighter to see. Usually if you see one singular, very bright dot, brighter than all the others going by itself, that's usually the International Space Station, which is also very, very cool to see because there are actually people living there. And it's kind of weird to think about that on that tiny dot. There are, I think, 7 people on there doing science or sleeping, or if you're Chris Hadfield playing your guitar. But definitely, most likely satellites. Yeah, possibly Starlink. You can check out heavensabove.com, which will break down. It has all the Starlink trails and you can break it down to your area and it'll tell you when they'll be visible.
Absolutely. Heavens Above is a great star map. You can also download an app if you're a smartphone user. I use ISS Pass. It gives me a little alert if the ISS is going to make a pass above me, because sometimes it's lower to the horizon. So it gives it like a grade of like, this is going to be a 2 out of 5 or like a 5 out of 5. Just how bright it's going to be. I certainly did see the ISS pass a couple times a night because it orbits around our Earth so quickly. Something like, is it 88 minutes, I think?
It's like, yeah, it rounds up to 90, 16 times or so. And yeah, so if you see it one night and there's a chance an hour and a half, you'll see it again the same night, which is very cool. Yeah.
So cool. Well, thanks, Ange, for that last question. You know what? We are going to be changing up our schedule because we're going to be right back here next Thursday to switch up because we didn't want to coincide with the Perseid meteor shower event. So you know what? Come and meet us right here. Ask an Astronomer on August the 3rd.
Not the 3rd.
Not the 3rd. What's the date?
I think it is the 6th, isn't it?
You know what? You're totally right. Why did I say the 3rd? Thanks, Marley. That's why you're here, to save me.
I literally had a heart attack. I was like, oh no, it can't be the 3rd. I'm not here.
It's going to be next Thursday, August the 6th. We will see all of you then.
Excellent. Bye, everyone.